All right, what up, you guys? So this question is about tRNA. My question for you is, what process are tRNAs involved in? Right, tRNAs are involved in translation. They are the link between RNA and the protein. Okay, cool. Keeping that in mind, we want to sketch the tRNA that will bond to the first codon and the mRNA from the previous question. So let's go ahead and pause and bring back the mRNA from the previous question. Okay, cool. mRNA from the previous question, and it's the first codon. The first codon of any mRNA will always be the AUG. Doesn't matter for this question though. So let's go ahead and think about the tRNA. The tRNA has a couple important things. So the anticodon, I think, is one of the most important things. It's what pairs or bonds with the codon. So think about it here. What would pair? What nucleic acid would pair with an A? It would be a U. What nucleic acid would pair with a U? It would be an A. And what nucleic acid would pair with a G? It would be a C. So it would be UAC here. Obviously, the letters are important, but what else is always important when you're thinking about nucleic acids? Right. You should be thinking about the directionality. So it's still anti-parallel. So if this is the 5' end of the mRNA or the messenger RNA, what end must this be of the tRNA? It must be the 3' end, so we're still anti-parallel, and this must be the 5' end. Cool. So tRNA kind of looks like a T. Just gonna draw it out like that. So this is the 5' end of the anticodon. This must means this is the 5' end of the tRNA, and this is the 3' end of the tRNA. So we already did a lot. We already did this right here. We have anticodon. We know our anticodon is 3UAC5. We have our 5' ends written down and our 3' ends. Let's think about where the amino acid is attached. So tRNA is just like mRNA in the fact that it's made of nucleic acids. Where could you attach something to the end of a nucleic acid, the 5' end or the 3' end? Let's go ahead and look at a nucleotide to help us figure that out. And you guys kind of unlocked a bonus question here. This nucleotide, is it from DNA or from RNA? So we'll answer that first and then get back to what's at the 3' and what's the 5' ends. DNA in RNA, the D is for deoxyribose. And the R in RNA is for regular ribose. Let's go ahead and see if you can pause this video and number this. Right, so number 1 is where the nitrogenous base is. That's the most important. 2, 3, 4, 5. Cool. So deoxy for DNA is lacking in oxy or lacking in OH groups. It's lacking that oxy on O2. So once we draw that oxy back in, that's when we have the R or ribose for RNA. So this nucleotide that I drew here, or that was originally shown here, was from DNA. And you could tell because there is no OH group at the 2'. Okay, cool. So you probably, this is a tangent, but it's important. You probably noticed by now that this class is very detail oriented, so I'll try and throw in some details when I can. A good place to ask about clarification of details is to come to Drop-In or email me. Anyways, this is important for us. So we know that this end right here is a 3' end of the tRNA. This end right here is a 5' end of the tRNA, and we want to know where the amino acid is attached. So where is somewhere where we could add something? At the 5' end of any nucleic acid, there's a phosphate, and at the 3' end, there's an OH. Which one of these groups can you always do a condensation reaction with? right? We talked about OH, you add to the alcohol. That's a good way to remember that the 3' end is where the amino acid is. And what amino acid is going to be attached here? That's a good question. An easier way to think about this question is, what does AUG code for? It codes for methionine. So that's the amino acid that will be attached at the 3' end. Okay, cool. So being able to go from the codon of an mRNA to the anti-codon of a tRNA and connect that with the amino acid here is super important. So let me know if you have any questions on this one.